So in this video, we're going to continue discussing our polar graphs, looking at the example r equals 5 plus 5 cosine theta. And we'll approach this similar to how we did the last couple, where I'm going to graph this now like I would have earlier in the course. So we've got a cosine graph that's going to be shifted up 5 units with an amplitude of 5. So our graph that we're going to put together, with this being the theta axis and this being the r axis, we would need a pi over 2, a pi, 3 pi over 2, and 2 pi to get a full cycle. Again, it's a cosine, but it's shifted up 5 units. So if we call this a 5, and I treat this as my midline, then my maximum values would occur at 10, and my minimum values would occur at 0. So from 5, we go up 5 for an amplitude, down 5 for the amplitude. Cosine starts high, comes down to the midline, down to the minimum, back up to the midline, and then back up to the maximum. So if I sketch this in, there's our graph. And I'll go through and I'll label points again, r theta. So 10, 0, we have 5 pi over 2, we have 0 pi, we have 5, 3 pi over 2, and we have 10, 2 pi. So looking at what we need here, we're going to need the 5th circle, and we're going to need the 10th circle. Now, obviously my graph doesn't consist of that, so once again, I'll treat each of these concentric circles as 2. So this would be r equals 2, 4, 6, 8, 10. So 10 would be the outer one. 5, actually, what I'll do is I'll go ahead and sketch in another curve. Let's see, right about here. This would be our 5th circle based upon how we've got things labeled. So I'll sketch that one in there, and I'll treat that one as my r equals 5 circle. So let's see what happens. We've got 10, 0, so out to 10 at 0. 5 pi over 2, that would be right here. Then we'd have 0 pi, which is back at the pole. 5, 3 pi over 2, which would be down here. And then back to where we started, 10, 2 pi. So when I connect these dots now, the thing you'll have to remember is how we transition now from here to here to here. And so with a little bit of experience, you'll see that this thing comes out through it, back in, back out, and then into where we started. So that blue graph there that we have, that's actually called a cardioid, and you can see how it kind of looks like a heart on its side. All right, so for the next graph, we'll have 1 plus 2 sine theta, which now we've got a sine curve that's going to be shifted up 1 unit with an amplitude of 2. So to graph this being the theta axis, this being the r axis, all I should need are my standard pi over 2, pi, 3 pi over 2, and 2 pi, take marks. Shifted up 1 unit means our midline is going to be at 1, and with an amplitude of 2 puts me at a 3 and a negative 1. So for sine, which starts out on the midline, then it goes up, this is what we're looking at. I'll go ahead and connect these dots. And I'll label, again, r theta. R theta puts us at 1, 0, 3 pi over 2, 1 pi, negative 1, 3 pi over 2, and 1, 2 pi. So I'm going to go ahead and plot these points now on our polar graph. We've got the point 1, 0, which would be right here. We've got the point 3 pi over 2, which would be out on the 3rd circle, but pi over 2. 1 pi, puts us right here. Negative 1, 3 pi over 2. It's right there. And then back to 1, 2 pi. So to connect these dots, there's something that we'll have to pay real close attention to. Notice going from the first point to the second point right there. Maybe I'll even connect these in a different color. Going from the first point to the second point brings us around like this. Then from there, going into this point, we come back down. So nothing too tricky there. But notice, we now need to go from this point to this point. We need to go from this point to this point. Now, to connect those 2 points, notice this graph goes across the theta axis. Now, we haven't paid much attention to it because it's not on one of our standard tick marks, but by going through the theta axis, just like it's meant in all the other examples, it's got to go through the pole. So as I travel from this point to this point on the polar graph, I'm going to need to go through the pole. So connecting these points, I come down through and back up, and then similarly, when I go from this point back to where I started, I'm going to need to travel through the pole. So I'll come back down through and connect it up. So what we have here is a graph with actually a loop in the middle of it. This is called a looped lemicon, and it's one of the special polar graphs because of how it kind of doubles up on itself.